The gauges told the story before Roach's mind could fully process it. Fuel pressure dropping, oil temperature climbing. The Pratt Whitney R-2800 beginning that telltale sputter. 18 cylinders misfiring in sequence as starvation set in. Below, the patchwork of occupied France stretched endlessly. Behind, the English Channel had consumed fuel at a rate the mission planners hadn't anticipated. Ahead, safety remained tantalizingly close, impossibly far. Then he saw it. An airfield, grass strips, familiar layout, the kind of forward base he'd operated from dozens of times. Roach committed. The massive Thunderbolt, 13,500 pounds of American engineering, fuel and ammunition, dropped toward the field. Flaps down, gear extended. The familiar rumble of touchdown, tires kissing grass. The airframe settling with that characteristic P-47 solidity that pilots either loved or complained about, depending on the day. He followed a ground vehicle toward parking, throttled back, began shutdown procedures. And then he saw them. The Balkenkreuz. Black crosses on wings that should have shown Allied roundels. His stomach dropped faster than any combat dive he'd ever flown. German soldiers materialized around the cockpit before the propeller stopped spinning. Rifles raised. Roach's hands went up slowly, carefully. His war as a combat pilot, 4 months of missions, 22 sorties logged, ended in that moment. Stalag Luft awaited, but the aircraft he'd just delivered intact. Its war was just beginning. Within 6 hours, the Thunderbolt was unrecognizable. German ground crews worked with methodical efficiency. Paint rollers transforming American olive drab into Luftwaffe gray-green. The white star and bar disappeared beneath fresh Balkenkreuz. RLM-04 yellow, bright, unmistakable, covered undersurfaces and tail. The standard recognition marking for captured aircraft. The message to German anti-aircraft gunners: don't shoot this one down. We need it. Armed guards formed a perimeter. Engineers arrived with cameras, notebooks, measuring instruments. Preliminary examinations began immediately. External dimensions catalogued, access panels photographed, markings documented. The fuselage data plate revealed serial number 4222490. Manufacturing date, Republic Aviation specifications. Someone translated the English stencils near the cockpit. Warnings, fuel grades, operational limits. Every detail mattered. Before we continue, click that subscribe button. Like this video, and let me know in the comments where you're watching from. It brings me great joy knowing that these war stories and lessons get to people all over the world. Your support helps us bring more thrilling war stories, and trust me, you won't want to miss them. Now, let's get back to the story. By the third day, the aircraft was moving. A Luftwaffe transport towed it to a railhead. Loading onto a flatbed railcar required careful calculation. The P-47 was wider, heavier than anything in standard German fighter inventory. The journey northeast toward Rechlin took 48 hours through a landscape increasingly scarred by Allied bombing. Past factories running triple shifts to replace losses. Past training fields, where German pilots learned to fly aircraft that would be obsolete before they reached the front. Past the visible evidence of a war economy stretched beyond sustainable limits. At Rechlin, floodlights illuminated the Thunderbolt as it rolled off the transport. Technicians and engineers gathered. Test pilots studied the profile. This wasn't just another captured enemy fighter for academic examination. This was an artifact from a different kind of war. A war where abundance replaced ingenuity, where weight didn't matter because power was unlimited, where good enough never entered the design vocabulary. This wasn't a plane. It was a national mirror, and Germany was about to see a reflection it couldn't ignore. The workshop at Rechlin smelled of metal, oil, and German cigarettes. Under mercury vapor lamps, engineers began the methodical dissection. Each access panel removed revealed another layer of American manufacturing philosophy. Zeus fasteners, quarter-turn quick release, allowed panels to drop away in seconds. German aircraft required tools, time, careful bolt removal. Here, maintenance accessibility had been designed in from the beginning. One engineer counted 37 major access panels, all standardized, all interchangeable. The fasteners themselves told a story. Precision-machined identical tolerances across hundreds of components. No hand-fitting required. No craftsman spending hours achieving perfect clearances. These were parts made by the thousands, by workers who'd never seen an aircraft, in factories organized around production volume that German industry couldn't conceptualize, let alone match. Hans Werner Lerche approached the cockpit with professional curiosity. At 28, he was already Rechlin's chief test pilot, methodical, analytical, a man who'd survived 125 aircraft types through preparation rather than luck. He settled into the seat and immediately understood why German pilots complained about cockpit complexity. The instrument panel contained what seemed like twice the number of gauges found in German fighters, he would write in his logbook. Strange levers controlled systems I had never encountered. The turbo-supercharger alone required understanding exhaust flow management that we considered theoretical. The electrical system confused him most. Circuit breakers instead of fuses, multiple redundancies, systems designed assuming component failure rather than hoping for reliability. It was engineering pessimism, and it worked. The R-2800 double wasp dominated the forward fuselage. 18 cylinders arranged in 2 radial rows, 2,804 cubic inches of displacement. At standard boost, 2,000 horsepower. With war emergency power and water methanol injection, 2,300 horsepower. Germany's best radial, the BMW 801, produced 1,630 horsepower maximum. The gap wasn't incremental, it was categorical. But the real revelation sat behind the engine, the turbo-supercharger system. Exhaust gases drove a turbine spinning at 21,000 RPM, forcing compressed air into the engine at altitudes where naturally aspirated fighters choked. German engineers had abandoned turbo-supercharger development in 1940. Too complex, too unreliable, too resource-intensive. America had made it standard equipment. The metallurgy stopped conversations. Exhaust manifolds fabricated from Inconel, a nickel-chromium alloy Germany couldn't produce in meaningful quantities. Turbine components machined from materials that required exotic refining processes. The Germans took samples for analysis, already knowing their metallurgists would confirm what was obvious. These alloys required resources Germany no longer controlled. Armament examination produced quiet admiration. 8 Browning M2 .50 caliber machine guns, 4 per wing, fed by ammunition systems engineered with jeweler's precision. Each gun's breech sat in a heated bay, preventing freeze-up at altitude, a problem German pilots accepted as inevitable. The feed mechanisms incorporated anti-jam features, spent casings ejected cleanly through dedicated chutes. When engineers test-fired a single gun into ballistic gel, the wound channel was catastrophic. Multiply by 8. The firing rate delivered 800 rounds per minute of half-inch projectiles. Nothing in the Luftwaffe's inventory could survive that convergence zone. The armor plate surrounding the cockpit measured 9 mm at the seat back, with additional layered protection at headrest and floor. Bulletproof glass, actually laminated layers with vinyl interlayers, was 38 mm thick. German fighters carried armor as afterthought additions. The Thunderbolt was built around armor from the start. Then Lerche flew it. Low-altitude performance matched German combat reports: sluggish, heavy, unresponsive. But at 25,000 feet, the transformation was absolute. The turbo-supercharger delivered sea-level power in thin air. The Thunderbolt accelerated, climbed, dominated. In a dive, it was untouchable, terminal velocity exceeding 550 mph when German fighters risked structural failure past 450. Lurch's final logbook entry was clinical. Superior in every measurable category at altitude. We have nothing equivalent. The official Luftwaffe technical report, filed March 1944, read like a confession. The P-47 demonstrates complete air superiority above 7,000 meters. Engagement at these altitudes is not recommended unless numerical advantage exceeds 3.1. Even then, success is unlikely if the enemy elects to disengage. Tactical recommendations followed with clinical precision. Avoid high-altitude interception. Force combat below 4,000 meters, where German fighters retained maneuverability advantages. Press attacks aggressively before the Thunderbolt reaches fighting speed. Never pursue into dives. Accept that damaged P-47s will escape. They possess survivability margins. German aircraft cannot match. The report's final paragraph carried unspoken weight. Replication of the turbo-supercharger system, armor integration and armament installation would require industrial capacity and material resources currently unavailable. Translation: we understand what they've built. We cannot build it ourselves. The numbers told the story the engineers couldn't articulate. In 1943, Republic Aviation's Farmingdale plant produced 2,103 P-47 Thunderbolts. Evansville's new facility added 2,645 more. Total, 4,148 aircraft in 12 months. That same year, Focke-Wulf manufactured approximately 3,400 FW-190s across all variants, Germany's most successful fighter production program. But airframes were only the beginning. Pratt Whitney's East Hartford plant delivered 8,940 R-2800 engines in 1943. Each required 2,000 precision-machined components, exotic alloy forgings, and quality control processes that rejected anything below specification. Germany's entire BMW 801 production reached approximately 6,200 engines, and BMW was cannibalizing quality to meet quantity, accepting tolerances that American inspectors would have condemned. The supply chain differences were more devastating than the production numbers. Every P-47 rolled off assembly lines with 8 factory-fresh Browning machine guns, full electrical systems, radio equipment meeting standardized specifications, and instruments calibrated to identical tolerances. Replacement parts were interchangeable across the entire fleet. A wing panel from Farmingdale fit perfectly on an Evansville airframe. German logistics were an exercise in improvisation. Fighter units maintained extensive machine shops to hand-fit replacement parts. Engines arrived with varying specifications, depending on which subcontractor fabricated which components. Armament systems required constant adjustment. What American crews considered basic maintenance, German ground crews approached as skilled craftsmanship. Oberleutnant Heinrich Sturm, who flew against P-47s over France, later wrote, "We learned to respect the Thunderbolt, not for its agility, it had none, but for its relentlessness. You could hit them, see strikes, watch pieces fall away, and still they continued. They absorbed punishment that would have vaporized our aircraft and simply flew home." Lurch's private notes, discovered decades later, revealed the engineer's perspective beneath the test pilot's objectivity. Every component revealed decisions we could no longer afford. They chose durability over weight, redundancy over elegance. Their pilots fly, knowing their aircraft will protect them, will bring them home. Ours fly, knowing survival depends on not being hit at all. This is the difference between abundance and scarcity made visible. A Rechlin metallurgist's report contained a single devastating sentence. The aluminum alloys in the wing spars exceed purity levels our current refining capacity can achieve. They weren't just behind. The gap was widening, monthly, inevitably. By mid-1944, Republic Aviation would produce 1,200 Thunderbolts per month. Germany's entire fighter production, all types combined, would struggle to exceed 2,000. The Thunderbolt's lesson was complete. Industrial capacity determines outcomes. Genius without resources loses to competence with abundance. By June 1944, the strategic implications of the Rechlin evaluations had crystallized into operational reality. The Luftwaffe controlled German airspace, barely, but had effectively ceded the skies above 20,000 feet to American fighters. Not through tactical defeat, but through industrial impossibility. German fighters could reach those altitudes. They simply couldn't compete once there. The air superiority equation had inverted. Traditionally, the side with better pilots, superior tactics, or technological edge won control of the sky. But the Thunderbolt, and the industrial system behind it, had introduced a new variable: sustainability. American fighters appeared in greater numbers each month. Losses were replaced within weeks. Damaged aircraft returned to service with factory-fresh components. The 8th Air Force wasn't winning through brilliance. It was winning through inexhaustibility. German fighter production reached its wartime peak in September 1944. 3,031 aircraft, an impressive surge until contextualized. That same month, American factories delivered 3,812 fighters across all types, plus 2,334 heavy bombers. The output gap wasn't narrowing, it was accelerating. And unlike Germany's numbers, inflated through stripped-down variants and deferred quality control, American production maintained specifications. Every aircraft delivered was combat-ready, fully equipped, supported by logistics chains that delivered spare parts faster than combat could consume them. The Thunderbolt's lesson had mapped directly to strategic air superiority. By late 1944, P-47s ranged across Germany with impunity, not because Luftwaffe pilots lacked courage or skill, but because the industrial foundation of German air defense had fractured. Fuel shortages grounded fighters. Replacement parts never arrived. New pilots received 60 hours of training instead of 240. Meanwhile, American pilots flew aircraft that had been test-flown, inspected, and delivered with tolerances measured in thousandths of an inch. The captured Thunderbolt at Rechlin flew evaluation missions until fuel shortages ended German test programs entirely in early 1945. As Soviet forces approached, Rechlin personnel attempted to evacuate the most valuable captured aircraft. Most were destroyed to prevent recapture. A few, including partially disassembled P-47s, were discovered by Allied intelligence teams in abandoned hangars. Photographs from May 1945 show rows of filing cabinets in Rechlin's documentation facility. Thousands of technical reports, evaluation summaries, metallurgical analyses, a comprehensive education in American industrial warfare. Meticulously documented, completely irrelevant. The Germans had learned everything. They simply lacked the capacity to apply the knowledge. One photograph shows Lieutenant Roach's Thunderbolt, serial number 42-22490, partially stripped in a corner hangar. Cowling removed, engine exposed, instrument panel photographed and catalogued. An artifact of a 90-minute flight that ended in capture had generated 18 months of German engineering analysis. The reports filled 3 archive boxes. The P-47 Thunderbolt didn't invent new physics of flight. It didn't break through some theoretical barrier or discover revolutionary aerodynamics. What it did was simpler and more devastating. It embodied a national decision to turn industry into an inexhaustible weapon, to build not the cleverest fighter, but the most survivable, not the lightest, but the most powerful, not the most elegant, but the most effective. Every component, from Inconel exhaust manifolds to redundant electrical systems to armor plates surrounding the cockpit, represented choices only abundance allowed. Germany had brilliant engineers, brave pilots, and sophisticated tactical doctrine. But they were fighting an opponent who'd decided that pilot survival, material superiority, and production volume mattered more than efficiency or elegance. The captured Thunderbolt was never just an aircraft. It was evidence of industrial certainty. And against that certainty, excellence wasn't enough.